Okay, so now that we have our number of moles of base, how then do we find our concentration of our base? So our concentration of base is what we're trying to find. We have our volume of base is equal to 25 mils, or 0.025 liters. And our moles of base is equal to 0.0041 moles. So we plug that into our equation. So concentration of base is equal to 0.00411 moles divided by 0.025 liters. And we get 0.01464 moles per liter. 0.164 moles per liter. And we do therefore statement. So therefore, the amount concentration of sodium hydroxide is 0.164 moles per liter. Okay, so that's a situation where we have 1-to-1 ratio of acid to base. What if that's not the case? Let's take a look at an example where that is not the case. So in this case, we have a 1 gram sample of potassium carbonate dissolved in 100 mils of water. A titration of this sample requires 24.20 milliliters of nitric acid to reach the endpoint. Calculate the amount concentration of nitric acid. So we're given a little twist here because we don't have the concentration of our solution yet. So we're given a mass. So well, we can handle this. Our mass of our base is equal to 1 gram. Our volume of base is equal to 100 milliliters. And our volume of acid is equal to 24.20 mils. So it says calculate the amount of concentration of the nitric acid. So we're trying to find our concentration of acid. So we're going to use our CAVA equals CBVB, and C equals N over V. So it tells us straight up, write a balanced chemical equation for the reaction. So potassium carbonate is our substance. So K2CO3. And we are reacting that with nitric acid. So we're going to produce potassium nitrate. The potassium will pair up with the nitrate. And hydrogen carbonate. Now, how is that a neutralization, you're asking? Well, remember that hydrogen carbonates always decompose into water and carbon dioxide, right? So we're going to leave it as its full form, but that's how that happens. Okay, so is this balanced? Well, I look at potassium straight off the top. Nope, I need a 2 in front to balance that out. That makes me have 2 nitrates, right, as well. So I got to go back to this side and I need 2 in front of there. Do my hydrogens balance out? I got 2 and 2, and it looks like everything else does too. Carbonate, carbonate. Good, so it's now balanced. So this is a case where I have 1 mole of base to 2 moles of acid. So I have to look at my mole ratio. That's why the mole ratio is important. From the last question, it wasn't so important, but here it is. So the first thing I need to do is convert all my volumes of solution into liters. So my volume of base is 100 mils, or 0.1 liters, and my volume of acid is 24.20 mils, or 0.02420 liters. Okay, now it says use the mass and molar mass of potassium carbonate to determine the amount of moles of potassium carbonate, right? So of course I need to do that because I don't have it yet. So I need my molar mass of potassium carbonate, and I have that at 138.2 grams per mole. You would have to use your periodic table to find that. And the mass is 1 gram, 1.00 grams specifically. So moles is equal to question mark. So moles of base is equal to 1 gram divided by 138.2 grams per mole. And that would be equal to 7.24 times 10 to the negative 3, or 0.000724 moles. Depends which way you like to write it, that's fine. So now I have to find the moles of my nitric acid using the mole ratio. So what's my mole ratio? Go back up here, 2 nitric acid to 1 mole of potassium carbonate. I always put what I'm trying to find on the top, just means less math. So 2 moles nitric acid equals X moles nitric acid over 1 mole potassium carbonate. And I had 0.00724 moles. So X is equal to, multiplying that by 2, right? Times 2, essentially, right? So 0.01447 moles. Good, so I now need to go back and put that into my C equals N over V equation and finish that up. So the moles of acid is equal to 0.01447. The volume of my acid from back at the beginning was 24.20 mils, or 0.02420 liters. And I gotta find that. So CSA equals NA over VA equals 0.01447 moles over 0.02420 liters. And that is equal to 0.598 moles per liter. Now, why did I use 598? Well, I go back to my question, right? A lot of you are missing this. Go with the least amount of significant digits in your question. So we have that, this counts. Remember, zeros count in chemistry. So we need to have 3 digits. Therefore, the amount, concentration of nitric acid is 0.598 moles per liter. Fix that little 3 I drew there. Okay, so you've had an example of a 1-to-1 ratio and one that's not 1-to-1. So you've got some practice questions on page 485. Do as many as you need to make sure you understand this, and make sure you reach out if you have any questions. Take care. Bye for now.